Okay, so Keith, as you can see, we're busy with the electronic system now, the camera system. You can see the gauges once again, they're hanging in furthest from those parts of the chassis, as far front as possible, and as far back as possible.
Okay, so Keith, before we carry on, there's just a few questions I want to ask about the targets that you were using. So first of all, with the manual system, we have increments of 10 on the target that you used with the manual system.
Yes.
Now, on the laser system or the computerized system, I see there's a sound wave board here. So the difference between the two is obviously that the camera would pick up the sound waves on this particular board. However, I noticed that there's a number on this board. What is this number actually currently for?
Each number, at the end of each number, at the end of these long numbers, you'll see there's a 1, a 2, a 3, and a 4. That gives you the position that the target must go on. Okay? So if this was a position 1, it would go to the left front, same as a position on the tire.
Okay.
If it was 2, the 2 goes over there. If you want to show on that board there, it says 2 on that board.
Right.
Okay. So then 3 would be on the left rear,
Okay.
and 4 would be on the right rear.
Right here.
Yeah.
Okay, now, so obviously your manual system and your computerized system, as you can see, the boards are totally different. You cannot interchange them. Now, the other question I want to ask you is with the camera that is set up here, is this camera interchangeable? Can you use it on the other side of the vehicle with the computerized system, or does it have to remain on the right side of the vehicle?
Both cameras are interchangeable. In fact, you can even have them upside down. One can be upside down. You're still going to obtain the same values. So one camera is not dedicated for right and one camera left. They're interchangeable.
Okay, so that explains why these boards are totally different. As you can see, we've got the manual system and we've got the computerized system. And what we're going to do now is we're going to carry out the radial run-out checks again with the computer system, and we're going to try and see if the values differ from the manual system that we currently did previously. So let's do the checks.
Okay. Right, John, do you want to jack the back axle up?
Okay, so now you're placing your target, your laser target with the sound waves, you're placing that on the position 4.
That's correct, yes.
Right.
And sometimes we find that the cameras are too close to the boards.
Yes.
And it cannot pick up the board. It's too close.
Yes.
So all you do is you flip the board around.
Okay, so that is very important. So as you can see here, we have a smaller sound wave on this side versus the other side
That's
of the
correct,
board.
yeah.
And that is merely to enable the camera to pick up the sound
That's
wave
correct.
if the camera is too close.
That's correct. And once again, you can have the one board like this, and you can have the other board facing the correct direction.
Yes.
Your values are still going to be the same. It doesn't interfere with the values.
Okay. So what we're going to do is we're going to turn this board back again. We're going to turn it back, and we're going to now do the radial run out with the camera up against the sound wave board.
That's right, yeah.
Right. Let's do that.
Okay, I think before we carry on, we check the calibration on the laser. Let's check the calibration on the camera. Okay, with the system, when calibrating, you can't make a mistake.
All right.
Because there's a green light on the camera, and it will only come on when the camera's in the correct position. So the computer actually tells you to aim the camera slightly up.
Right.
The green light's on.
Okay.
Push OK.
Right. So that's now taken a measurement.
That's taken a reference, so now it says aim the camera slightly down. Only when the green light comes on.
Okay.
Green light's on. Now it tells you to aim the camera in a horizontal position. Green light's on.
Right.
Okay, you take the camera off, turn it around.
Now, why are you turning it around now? Is this to make sure that it's 100%?
Yes, it all forms part of the calibration process.
Okay.
The green light's on, push OK. Calibration complete.
So this camera and the calibration with the bracket now is complete or not yet?
The the camera's been calibrated now.
Right.
So now you can see, here's your calibration values. This is what they were. Remember, there are 60 minutes in 1 degree.
Yes.
So half a degree is 30 minutes. A quarter degree is 15 minutes. You can see it's out by 2 minutes, which is so fine.
Okay.
Your millimeters for the toe,
Right.
0.1 millimeters over that distance, over the distance of this vehicle, 0.1 millimeters. So this is what the calibration was at.
Yes.
Now it's on 0.
Okay.
Okay.
So now we're going to do the measurements now.
Now we calibrate the other camera.
Okay, so now we've calibrated the one camera, and now we're going to do the other camera now to ensure that this camera is calibrated.
That's correct.
So once again, we're going to tilt it down till the green light comes on, horizontal till the green light comes on, and then obviously we're going to turn it upside down, and we're going to now just calibrate this now until it shows us that the camera is now calibrated.
Okay, once again, you can see the minutes, it's out by 2 minutes.
Yes.
Okay. The toe was 0.
All right.
Okay, so this calibration was,
Within spec.
yeah, it's within spec, and now we're ready to go ahead and measure the axle alignment.
Right. Let's do that.
So yeah.
So you entering all this on the computer now,
All the customer's information.
right? And then obviously we would have to put in the configuration of the vehicle
Yes,
on the computer.
that's correct.
So that we can align it correctly.
That's correct. Look at the computer here now.
Right?
We've put in all the information, the customer's information.
Correct.
Okay. Now we'll go up here. Now we need to select the configuration.
Okay.
Okay, so it's a 6x4.
6x4.
Double diff.
Right?
Okay. Selected that, then we go next.
Okay.
Okay, here you can see your battery life.
Yes.
It's an indication of how much life is left in your batteries.
Right?
Okay.
Now that battery light will be on your cameras.
On the cameras, yeah.
Yes.
So if I take the camera off,
I see. Okay.
see,
It gives
okay.
it clears it.
that's it. So then I'll put it back on.
Okay, I'll see what's
There we
happening.
go.
And then we're back again to
Yes.
power.
Okay, so now we have to select the axle we're working on.
Right, so that would be
that one
axle
there.
number 4.
Yep, select that one. And yeah, we're going to do the normal run out pretty similar to the mechanical
To the
system.
mechanical
Yeah.
system. So the same procedure that you did with the mechanical system, you're now going to carry it out with the computer system.
That's correct.
So the processes are exactly
the same.
All right, let's do the run out and let's have a look.
Is your sound on, John?
Yeah.
Okay, so we've taken the first reference now.
Right.
Okay. So now we have to rotate the wheel a half a turn, 180. Okay.
Right.
Same procedure.
So once again, green light comes on.
Push OK.
Okay.
Okay, there it tells you how far the caliper. Okay, so you can see it's at 3.6 now. Okay. So now I'm going to adjust it.
Okay, so now you can see it's way in the red.
Yeah. But now this arrow also tells you here. If you have a look at this arrow here, it tells you which way the camera must go.
All right, so this
Okay.
camera, theoretically speaking, has to go out.
That's correct. And as I'm adjusting it, you can see it changing on the screen.
Okay, so you have the green light there, which means that it is now 100% in line.
Okay, so we've been working with the white button, so now we go to the black one. You can see the arrows telling us
Got
to go that way.
towards.
So if you look on the screen there, it's 2.7.
Okay, Okay, so back again to the green, and we know that this camera is now 100%.
Yeah, so I'm just going to finish off now, another quarter turn.
Once again, you're checking it. Green light on.
green light
you've got
on.
the green
Run
bar
out
there.
complete.
So your run out check on this wheel position is now complete. So now what you're going to do is you're going to take this camera and you're going to move it to the other side.
We've got two cameras here, so we can work with the other camera
So
on
this
this
camera
side.
can be left.
This camera stays there. Okay. You've got a white button
Yes.
and you've got a black button. It's always important to remember which one you start with. So basically, at the end of the day, this white button is going to do one complete revolution. It's going to come back to that position. So I'm starting with it there,
Yes.
and we're going to do a complete revolution with it.
All right. So we're going to right.
So
Yes.
I'm going to take my first reference.
Yes.
Okay. Then you turn the wheel a half a turn. Still with a white button.
Yes.
We take the second reference.
Okay.
Now we adjust.
Right. So we
You can see the arrows telling us the camera needs to go that way.
Okay. So the camera is going to go out towards the left now.
Okay?
Okay. Right. And
Okay, so it's green. So we finished adjusting the white now.
right.
Okay, now we go to the black.
Okay, so we're doing exactly the same now with the black button, and it's telling us that the camera had to go out to the left slightly. We've adjusted it now, and now we've got a green bar there, which means that it's now
That's
color black.
correct. Now we're going to do a quarter turn for the white one. Needs to go to the position we started in.
Right. And I see we have a green bar there.
Yeah,
again.
that's 100%.
So this camera is now 100% color black.
That's correct. Now we can let the axle down and we'll go ahead and measure. See what measurements we get.
Okay, Keith, so we've measured the left-hand side of the vehicle now. The camera is calibrated there. We've measured the right-hand side now. And now we're going to check on the computer to see what the settings are so that we can adjust should there be an adjustment to be made.
That's correct.
Right, so how are we going to do this now?
Right, so we're going to exit this screen. This is the run out screen. We exit
Right.
this. And once again, we're working on the back axle here.
Yes,
Okay. Now we're going to go here. They got toe and camber after run out.
Right.
Can you see there?
yes,
We click on toe and camber after run out.
yes,
Now all we do is we aim the cameras to the board.
right,
Green lights on. Okay, we've done this side. John, you can do that side. Okay.
So what is this telling us now with
Okay.
the measurements that we've just recorded?
All right. So now let's work on the left hand side.
Okay,
Okay. You've got your toe on the left is minus 1 millimeter.
yes,
Your camber on the left is 9 minutes.
right,
Okay.
right,
The toe on the right is positive 4
Positive
millimeters,
4, yes.
0.4, and the camber on the right is 12 minutes.
Okay.
There's nothing you can do about those in normal wheel alignment adjustments. If they are bent, there is methods
That you
used for straightening.
Yes.
Okay. Now, the most important thing here is your out of square.
right,
Okay. It's 0.7
okay,
millimeters out of square. Okay. Positive means that the axle is running to the left.
yes,
Okay. If that was minus, the axle would be running to the right. Okay, so we've got this running to the left. Now we go back to my measurements on the mechanical system.
yes,
Okay. If you have a look here, my outer square was 0.8 millimeters.
yes,
Okay.
right,
My total toe, 1.2 millimeters.
millimeters,
Okay.
yes.
All right. So there's a difference of 0.6 there
yes,
on the total toe,
yes,
and there's a difference of 0.1 outer square, which is
virtually nothing.
it's nothing. Over this distance, it's nothing.
Okay, so once again, it just goes to show how accurate your measurements are with the manual system versus the computerized
That's
system.
correct. Yes.
So this is extremely important that consistency be maintained when doing alignment on the relevant axles on a vehicle.
Absolutely.
Right.
Absolutely.
So what we're going to do now is we're going to go and we're going to check the second drive axle now,
Yes.
as that is already in specification and no adjustments can be made.
Yeah, yeah, it's already specification. Now, I'm not going to perform the normal run out where we actually jack the vehicle up.
Yes.
This computer has a facility where you can actually drive the vehicle in half a revolution.
Yes.
It does the run out and it measures all these values at the same time.
Okay, so that's just another more advanced feature on the laser system compared to the manual system.
That's right. Yeah.
So
And this,
it's a lot quicker.
you'll see how much quicker it is. And you know, for guys that are doing new vehicle alignments or vehicle that's just come off the workshop floor,
Yes.
you know the suspension, everything is 100%. It's all in working order. Then you go ahead and you measure the rolling.
Okay, so we're going to do the rolling.
We're going to do the rolling on the next axle.
Right.
Okay.
Let's do. Okay, Keith, so what you've done now is you've moved the clamps from the rear drive axle to the front drive axle. Your cameras are already set, so you don't have to reset the cameras again. So we're going to do a run out check now by moving the vehicle slightly forward, which will mean we are turning this wheel 180 degrees. Is that correct?
That's correct.
Right, so let's do that and let's check what our run out is on
Okay.
that.
All right. So what I'm going to do now is I'm going to take a reference.
Okay?
Okay, there's a first reference. Second reference. Okay. Now I'm going to do the same on the other side.
Okay? Okay, so you've taken the reference on the right hand side now, you're happy with that. Now we're doing exactly the same on the left hand side to ensure that everything is lined up properly.
Correct. So the green light's on, push OK. Turn the camera to the backboard, green light's on, push OK. And John's going to drive it forward, half a revolution now.
Right. So let's do that. Okay, Keith, so as we see now, the truck has been moved slightly forward. We've done a 180 degree rotation on the wheel. Can you explain to me now what has been done?
Okay, in that half a revolution, Keith, remember when we were doing the normal run out, we actually jacked the vehicle up
Yes.
and we had to turn the wheels?
Yes.
Okay, now this, we've just driven the vehicle a half a revolution and it's compensated for the rim.
Yes.
So the rim clamp is calibrated to the rim and it's taken all your values. It's taken your outer square, your total toe, your individual toe, which is toe left and right, and your cambers left and right as well, all in half a revolution.
Okay, so there is absolutely no need to jack the vehicle up again to do all that.
No.
It was done in a matter of this wheel rotating 180 degrees.
That's correct. Yep.
All right, so let's have a look at the values and let's see what the values are.
So once again, you got your toe on the left is minus 0.5, it's half a millimeter.
Yes.
Okay. Camber is 0.
Yes.
Okay. Camber is 1 minute positive.
Right.
Okay. The toe on the right is 0.
0.
Okay. Your total toe obviously is 0.5. Because there's 0 and there's 0.5. So your total toe is 0.5.
Yes.
Your outer square positive 0.3. Okay, let's see what I got on this machine, on the laser system. My outer square 0.1
0.1
millimeters. So there's a difference of 0.2 millimeters.
Absolutely nothing.
It's nothing.
Nothing.
So the consistency in the equipment is it's so accurate.
It's actually nice to see that the manual system and the computerized system are so accurate with each other's measurements.
Yeah.
And just comparing your manual check and the computer check, there is such a little difference that there is no need for any adjustments to be made
Yeah.
on the rear axle. That's very impressive.
Okay, so now we're finished with the drive axles. Now we're going to move on to the steering axle.
Right,
Okay, so when you go in here,
right,
okay, and asks you, do you want to save your values before, after, right? So we're going to save it as before.
Now, we're going to save these values. How important is it to do a before and an after reading when doing wheel alignment?
It's always important to take the before values, okay, because you need to determine why the tire is wearing off like that, and you need proof why the tire is wearing off, and proof that you've actually adjusted the alignment.
So this is of utmost importance. Always obtain a before reading and an after reading to see what has been changed when the wheel alignment was carried out on the vehicle. This is crucial because this will explain to you as to why the steer axle tires are wearing with a specific wear pattern, or the drive axle tires are wearing with a specific wear pattern. This will be able to identify where this wear pattern is coming from.
Correct. Right, Keith, I just want to show you that this is a mechanical report.
Yes.
Okay, and you can see there is not one, how can I say, figure
Yes.
that indicates it's on zero.
Correct.
And so many times I've come across in the industry where you get a mechanical report like this and everything is zero.
But
That's
that-
impossible.
That, I was just going to say that is a mortal impossibility.
No, it is.
You will never get everything on a specific vehicle at 0 degrees. There has to be some tolerance or some measurement or increment that has to pertain to a value on that.
That's correct.
On that.
correct.
List.
And I'm talking from experience. I've been handed handwritten reports and they're zero. We often get asked a question, how does the wind affect this the system?
That is a very important question because only too often I've been told that when doing laser alignment and your targets are moving, that it throws the measurements out. Can you explain a little bit more?
Well, we're simulating wind blowing here at the moment, and you can see how much their target, how much the values are changing.
Yes,
As long as the camera can read the board,
yes,
and as long as that frame gauge doesn't move from left to right,
Yes.
it can swing as much as it wants to.
it will still pick
It's
up
still
the
going
sound
to pick up.
wave.
You can see how little it's moving.
Extremely.
Okay, so the wind doesn't actually affect it.
Okay.
Okay.
But Keith, so what you've explained to me on the rear axle is all within tolerance on the computer versus your manual checklist that you've done. The values are as close as can be. And now we're going to do the run out values now on the steer axle. So now we're going to measure caster, camber, and obviously toe.
Yeah, and kingpin inclination,
And
your
kingpin.
maximum turn, toe out on turns. All your steering axle geometry we're going to measure now. But before we do that, we actually have to do the rolling run out to compensate for the rim deformity.
Yes.
And to get toe and camber values.
Okay, so how are we going to do that?
Okay, same procedure as the back axle.
Right.
So we go here now, we select the front axle,
Right?
okay, and we go to toe and camber, rolling.
Okay.
Okay, once again, then we select one axle, because we only got two cameras, working with one axle at a time.
Right?
Okay,
Right.
so now it's the same thing now. Take the first reference.
Right?
And I must say, when you're doing a steering axle, remember a steering can turn. So now we've taken references. It is so important not to touch the steering when you're moving.
So once you've taken these readings now, and we're going to do the 180 degree run out check again, we're going to move the vehicle back so that it does a 180 degree turn. Yeah? You should not turn that steering
Don't
wheel
touch the steering
whatsoever.
at all. Not at all.
All right. So we're going to do that, and then obviously once that is done, we're going to take another reading and check again.
Yeah. So hands free. the toe on the left,
Yes.
the camber on the left, toe on the right, camber on the right. You can see the camber values are very much the same.
Yes.
Which means the floor is pretty level here.
Yes.
And that the tire pressures are right.
Okay.
Okay. The out of square, I need to straighten the wheels physically, but you can see the total toe is 1.6 toe out. Okay. I think that value is slightly higher than mine because I got 0.5 toe out, so 1 millimeter.
1 millimeter toe out on this on the steer axle is absolutely not.
Over that distance.
It's not.
Yeah. Once again, the values obtained with the mechanical system and the computerized system, they're very close.
Really close.
Very close. Okay. So now what we're going to do is we're going to actually drive the plates onto the truck onto the non-friction plates, and we're going to measure the steering axle geometry. Okay.
Right.
Now, they are so low.
Yes.
Okay. So the higher your wheel is elevated in the front,
Yes.
the higher your caster values are going to be.
Okay.
So this is more real time.
Okay.
Okay. And these plates, they're so durable, you can actually drive the truck onto them. You don't have to jack it up and put the plates in and then jack it up and take them off. You can drive it on and off the truck, no problem. Plates, no problem.
So it is important to use the correct friction plates.
Yes.
And not friction plates that are extremely high, because that will change the cost.
It's going to increase your cost of value tremendously.
Okay. Right.
You want to get the wheels to a straight ahead position now.
Yes.
Okay. So I'm going to go to in.
Yes.
We'll say before.
Yes.
Now in order to get the wheels in a straight ahead position, we go to align.
Yes.
We're going to go toe left and right. Okay, so you can see your out of square here is 1.6.
1.6.
That's the steering straight ahead.
Yes.
So all I'm going to do now, I'm going to turn the wheel on the non-friction plates to get that 1.6 down to 0. So we know the wheels are exactly straight ahead then.
All right. So once again, we're gonna turn it, and it's gonna come down. Virtually. You've got your out of square on 0. What is the next procedure now?
Okay, so now what I'm going to do is, I'm going to go in here now. Okay, I'm going to go to in, and save it.
Yes.
Okay. Now we want to measure all the steering axle angles. Right. From your maximum turn, your kingpin inclination, your caster, your toe out on turn. Right. We're going to measure that. Okay. Now we've got to aim the camera to the front.
So now it's going to pick up the sound wave now in the front, and back again.
And you leave it like that. Now do the same on the other side.
Right. Okay, so now once you've done that
Now the computer will actually tell you which way you want it to turn. Okay. And you can see on the computer here is a red arrow.
Yes.
Telling you to turn left.
right,
Now you're not always able to see your computer.
right,
You can have a look on the camera here. This arrow
yes,
is saying it wants to go that way.
yes,
Okay, to the left. So
Yes.
it means you must turn to the left. Okay, so now what I'm going to do is I'm going to start the truck.
okay,
Very important when you're measuring steering axle geometry, you've got to have your foot on the brake. Because what happens when you're turning and you don't have your foot on the brake, the wheels roll. Okay?
Okay.
So you're going to get incorrect values, especially on your caster.
so it's important to have your foot on
You
the
have
brake.
to have your foot on the brake.
Okay, let's do this.
work on the computer as well? Measured all the steering axles to measure. It's not very time consuming, and all the measurements have come out fine.
Okay, so just help me out. I've noticed that this one camera is upside down on the right hand side, and the camera on the left hand side is the correct way up.
Yes.
Would that make a difference on your values?
Okay, so we have a look at the camera. So you're saying this one's upside down?
That's correct.
Okay, we come around to this side.
Okay, this one
Okay,
is.
so this camera is the right side up.
Yes.
The securing screw up.
Yes.
Okay, I specifically did that because I want to show you what values we've obtained. So let's go to the computer and we can go through the values that we've obtained.
Okay.
Okay, so yeah, we've got the maximum turn on the left.
Yes.
It's 42 degrees 3 minutes. On the right, it's 40 degrees 7 minutes. Okay.
Yes.
Your kingpin inclination, 8 degrees 26 minutes.
Yes.
We've got 8 degrees 1 minute.
Wow.
Okay, so the values are very much the same. Your caster is 2 degrees 41 on the left and 2 degrees 51 on the right.
Yes.
10 minutes difference between the two.
That's absolutely
It's
nothing.
absolutely nothing. Your toe out on turns, 1.7
Right.
and 1.6. So you can see, even if the camera is upside down, your values are still going to be accurate.
So once again, it just proves to you that the consistency in the equipment that you're using is extremely important.
It is. It is. That's what I said before. That is a great contributing factor to our achievements in the alignment industry. A lot of it we put down to the equipment.
Wow. Well, Keith, I think that this has been a real learning exercise, and I'm glad that I could share this opportunity with you. And hopefully going forward, we can resolve a lot of customers or end users' issues on doing alignment the correct way. And I want to take this opportunity to thank you for allowing me to do this video with you, and obviously to Jocelyn on the equipment. I'm very, very impressed with this equipment, and it just shows you that quality equipment is worth investing in. So I would suggest that you follow Keith on his Facebook page, you on Twitter.
Not on Twitter yet. We're on YouTube and on LinkedIn as well.
And LinkedIn as well. Once again, just thank you, and please, folks, follow Keith on his YouTube videos and on his courses that he's offering on the computer and the training that he offers. And from our side, from Sumitomo South Africa, once again, please follow us on Twitter, Facebook, or Instagram. And remember, doing wheel alignment the correct way is the only way to lower your cost per kilometer. Remember, it's in your hands.
Thank Keith Phelps for joining us. He had a lot of questions that he needed answered, and I'm sure, Keith, that you're quite satisfied with the results that we found. Put your mind at ease. And I want to say thank you to McCarthy Commercial here in Boksburg for allowing us to use their facility. We have a static unit based here permanently doing wheel alignments for McCarthy's, and then we have mobile units as well that are running out there in the field that can come out and assist you. And please, people, follow our YouTube page, subscribe to it. It's not about my popularity, it's about assisting you in growing your knowledge in wheel alignments. Thank you very much.